All right, so let's begin today by warming up. And as usual, we got a couple of word problems up here. No big deal. They'll take just a couple minutes. First one, use a model, sketch the graph of a linear function, so you know it has to be a line, right? And with the following key features, the x-intercept is 2. So 2 over on the x is where it should cross the axis. The y-intercept is also 2, so up 2 for the y-intercept right there. And right off the bat, there you go. You got 2 points. It's supposed to be a line. So the only way it can possibly have 2 points and a line is if the line goes right through those 2 points, and that must fit all the characteristics of the rest of the things they describe, I assume. The function's decreasing for all values of x. Is that true? Yeah, we're good. The function's positive for x is less than 2. So when x's are less than 2, it is above the axis. Checks off. And as x goes to negative infinity, the left, the function goes up, cool, to infinity. And as x goes to positive infinity, it goes down. So everything is cool there. And that perfectly matches everything right there. So there's the answer on the board for that. All right, let's look at number 2 now. Number 2 flat out says, Sia, that's a weird name, Sia, fill a pitcher with water. The pitcher started with 0 ounces of water. So let's start, I'm not even going to read the rest. Let's start constructing a graph. She's filling something up with water. They're talking about ounces. That's a unit of like weight or something. So let's just say weight of water for what we get out. So let's see how much water there is. She starts with 0 ounces. So start your graph at 0. Makes sense. And after 8 seconds, the pitcher contains 64 ounces of water. So after 8 seconds, I guess this is time. After 8 seconds, you get all the way up to a weight of 64 ounces. So there's another point on my little deal. The function that models the situation is linear. So since it's linear, we know it's going to be a nice straight line segment that connects these two. And that's pretty much it, I think. What's the rest of the problem say? A, use the key features to sketch the graph. Kind of did that. And B, what is the end behavior of this graph? Explain. Well, what's going to happen to this graph as time goes on? The left doesn't make sense, right? Let's forget that. As we go to the right, this thing just seems to creep up and up and up, correct? So I would say that, let's fancy it up. Limit. As usually x goes to infinity, but our axis here is time. Let's use t for fun. Limit as the time goes to infinity of this thing I'm studying, which is like the weight. So maybe I'll just use w. So what happens as time goes infinity to this w thing? It just goes up and up and up to infinity. And that's a pretty good mathematical answer. In practice, though, this is about filling up a pitcher. So if you're filling up a pitcher with water, is it just going to go up and up forever? Eventually it's going to overflow, right? And the graph would change. So this is not a realistic end behavior for the actual situation. But as far as the actual graph is concerned, that's good enough for me. All right, let's do some LGs and get ourselves to work. Learning goals today. Review. Hopefully a lot of this is review from Algebra 1. How to graph linear equations and linear inequalities. I don't think anything today is particularly difficult. Maybe just need a little refresher on how to do it because you have done it before. Homework due today. Per usual, since this is a new lesson, you'll have new homework assignment online again. Normal 2-day turnaround on that. So today is Tuesday, therefore it'll be due on Thursday. right, 1.4 due. 1.5 is the new one. Let's go ahead and get started with notes. This will be section 1.5 today. Topic, graphing linear equations and inequalities, found on page 39 of your online textbook. Graphing linear equations and inequalities. So essentially all Algebra 1 is like graphing linear equations, I think. It's like line this, line that, slope this. I don't know. That's really all I know about it. There's probably some other stuff too, quadratics or something, but there you go. And we're not going to start with notes. Let's just look at some examples of how to graph a linear equation. Example number 1 says graph using a table. So what you can always do is, if you're trying to graph something, anything, you can solve for y equals something. So in this example, if they gave you x plus 3y minus 6 equals 0, guys, how would you move everything to the other side that isn't y? How would you move this x to the other side? Anybody? Subtract it. I like that. All right. So we'll subtract the x to the other side. Now it's a negative x on the other side, correct? Cool. How would you get rid of the 6? Add 6. You got it. So let's go ahead and add 6 to both sides. And lastly, you got this times 3 that you don't want to deal with, right? So you probably divide by 3. Or do they do that? Or they say times a third? I don't know what they say. Well, we'll just divide by 3. So y is negative x plus 6 all divided by 3. And that's a pretty fine answer for this thing. You got your graphing calculators. I want you to start relying on those a lot more. You don't have to. I mean, you should be able to do this by hand. But it doesn't hurt. By the way, dividing by 3 is the same thing as times a third. So instead of saying all of this divided by 3, I could have said the negative x plus 6 was times 1/3. They're equivalent kind of answers right there. So hit your y equals button on your calculator up top. If you haven't looked at the online tutorial about how to graph basic things, check it out. It's only like 10 minutes or something like that. And when you get to y1, type this in just like it looks. Maybe like 1 divided by 3, type 1 divided by 3. You'll need a fraction button. Just hit the 1 divide sign and the 3. That'll give you 1/3. Parentheses. Have you found your parentheses yet? They're like by the 8 or the 9 key or something like that, right above them. Something like that. Type in just like it looks. Hit enter. It's always a good idea to do a zoom 6 once you got things typed in. The zoom key's up in the middle. And you just hit number 6. It'll reset your window to something nice and pretty. And you should see something that looks kind of like that there. When you typed it in, make sure you hit negative x, not minus x. Don't hit the minus button by the plus. Hit the negative button down by the 0 key. You get something that looks like that? Ish? Okay, good. Then you can graph things, and that's pretty good. Alternatively, what you could have done is you could have distributed the 1/3 in. What's a third times 6? Anybody know? A third of 6? 2, yeah. Could have done this. And if you remember this stuff, mx plus b kind of junk, what's the y-intercept on this, guys? According to this equation, the y-intercept is 2, right? So it should have crossed up here at 2. And the slope was negative a third, negative going down, right? Rise over run, so it rises, actually goes down 1, right? Every time you go over 3. So I could go over 3, down 1, over another 3, down 1, and we could have constructed it by hand like that, and we got the same thing our calculator did, right? So I always want you to try and do both ways, okay? Don't make a lot of work for yourself, but your brain should be saying one thing, and your calculator should be completely agreeing with it. If your calculator and brain are saying the same thing, then you can be like 100% sure, yes, I did that right. All right, so that's how you do that. I would not recommend making a table like this. The example says making a table, but I know how we hate to painstakingly put numbers in and stuff like that. You could have just plotted some points, right? You could pick an x value, plug it in, get out a y value, plot it. It can always work for things like that, but Try to use your calculator if you can. Let's actually make a table, though, just to humor them. So let's try this one out. Graph 6x plus 2y equals 10. Let's make this stupid table. What's the thing missing in the table? The y's, right? So again, it's probably a good idea to solve for y right off the bat. Let's do a little bit of work, and we'll just get an equation for what y is. Y is this. So 6x plus 2y equals 10. Unwrap it for me, guys. Humor me one more time. How are you going to get y by itself? First, you're going to what? Probably subtract that over, right? Okay. So subtract the 6x over. Now it's a negative 6x when it's on the other side. And then there's a 2, right? So divide by 2. Now if you divide this side by 2, make sure you divide everything on this side by 2 every term. What's this divided by 2? Yeah, negative 3x. And positive 10 divided by 2 is a plus 5. So there's my equation for it. Again, I would probably go graph it. You know, tables are dumb. I'll set up the table, though. We'll just pretend we don't have a graphing calculator, but you should graph it anyway. You know, just always use your calculator. That's what it's there for. If they did give you a table to fill out, you can just take the x's and plug them in and see what you get. For this one, as you're typing in your thing, that's fine. I'll do it over here. If x is negative 1 and you plug it in, negative 3 times negative 1 is positive 3, which plus 5 would be 8. They gave you 0 for x. Who cares? Times 0 is 0, right? Plus 5 would be 5. 1, you plug it in. Negative 3 times 1 is negative 3. Negative 3 plus 5 is 2. And lastly, 3. Negative 3 times 3 is negative 9. Negative 9 plus 5 is negative 4. So based on the table, you have a lot of coordinates. You know when x is negative 1, y is 8. Something like there. Then you know when x is 0, y is 5. So 1, 2, 3, 4, 5. You know when x is 1, it's 2. And when x is 3, it's down at negative 4. 1, 2, 3, 4, something like this. And if you kind of see and connect them, guess what it is? It's a nice part, except for my art, it's a nice straight line kind of thing. And you should have got something like that when you plug in your calculator. Did you? Okay, good. So your calculator is saying the same thing as the table, which is saying the same thing as the graph, and everybody's in agreement. We're good there. So nothing too complicated there. One good thing that instead of just picking random points like these tables are doing, a couple of good points to pick are the intercepts. They are really easy. You only need 2 points, right, to draw a line. So usually the x-intercept and the y-intercept are handy. So they're saying graph 3x minus 2y equals to negative 12. Okay. Now, forget all the slide stuff for a second. For this, tell me something you know about a y-intercept. You know something about this point. Not the y-coordinate, but what? X is 0. Okay, so if I want to find the y-intercept, let's just plug in 0 for x. So for the y-intercept, x is 0. Plugging that in, that would mean, well, 3 times 0 is nothing, right? So all I really have is negative 2y is negative 12, and dividing by negative 2, you get y is 6. So my y-intercept is at x is 0 and y is 6. 0, 6 is a point on this graph. There it is, right there. 6 high, 0 left and right. If you wanted to find the x-intercept, where it crosses the x-axis, well, anywhere on the x-axis, y is 0, right? So we're going to let that lead us. If y is 0, plugging y equals 0 into the original equation, we get just 3x equals negative 12. And if you divide by the 3, you get x is negative 4. So 1, 2, 3, 4, right there at negative 4. There's my 2 points, and that's really all you need, right? The reason the intercepts are so good is because one of them is 0. If one of them is 0, plugging in the equation is just super easy, isn't it? See how quickly that collapsed down? That's the only reason they're saying maybe use the intercepts, because if you have the intercepts, Oh, it's easy to find them, and then you got 2 points, and it's easy to plot them like that. And you should have got a graph roughly looking like that. The answers aren't here, but look how much talky talk they did. It's not that complicated. Just x is 0 for y-intercepts, and y is 0 for x-intercepts. That's it. Any questions over that? I'm going a little fast, but I think you guys get the gist, right? Okay. Sweet. Moving right along. Here's another one. Using the slope and the intercepts. Now, this equation right here, it's in your friendly format, slope-intercept form. The slope is 3/2, right? The intercept is y-intercept -4. So if you got that, you don't need to go do everything from scratch. You can just make the darn graph right off the bat. Y-intercept is -4, so you know it crosses down at -4. 1, 2, 3, 4. There's my y-intercept. And also, you know the slope is 3/2. That means you rise 3 every time you go over 2, correct? 3 over 2. So 3 up. 1, 2, 3. Every time I go over 2 to the right, there's a second point, correct? And we're pretty good. We got ourselves the intercept. We got ourselves the point that they gave us after we figured out our slope. Connecting them looks something like that. And again, your calculator, if you typed it in your calculator, should look exactly like that. So be using both resources. Cannot overemphasize how important that's going to be right there. All right, moving right along. Next topic. Graphing linear inequalities is the second thing. Any questions over just graphing lines? Kind of just use common sense, right? Intercepts, some points, slopes, and things like that, and graph it. Inequalities is slightly different. This is probably what I think you need a refresher on more than the former. But if you have an inequality, what's that mean? That means the greater than symbol, or the less than symbol, or greater than or equal to symbol, or anything like that. So an example of an inequality is something like this. Y is greater than x plus 2, or y is less than 3x minus 7. Those are good examples of inequalities right there. And they got a whole bunch of terminology here. You know, I wouldn't get too bogged down in that. Just so you know, a boundary is a line or a curve. So the boundary of the first equation I threw on the board would be the line y equals x plus 2. The boundary of the second would be y equals 3x minus 7. So you kind of just use the normal equation for the line, forget their inequalities for a second, and graph them. You're either going to make a closed half plane or an open half plane. I would not get too bogged down in that terminology. It's really, really, really simple. What I would get bogged down in here is this slide right here. This slide kind of summarizes everything you could possibly need to know to graph a linear inequality. So if you want to jot that down, be my guest. This is the big notes for the day. When you're graphing a linear inequality, your answer will be a whole shaded region. Remember doing that in Algebra 1? We had to shade a whole region, above a line or below a line, same kind of thing here. Just like an equation, if you're going to graph these, the first thing you need to do is solve for y. If you got an equation y equals 6x plus 2, just like the last example, you could use the intercept and the slope to graph it by hand. You need the same thing for your inequalities. So solve for y first. And when you are solving for y with an inequality, remember you're doing the same thing you do with an equation. You're moving things from one side to another. You're dividing by stuff. But for crying out loud, when you are working with an inequality, remember that if you happen to multiply or divide by a negative, you have to flip your inequality. It's always something to be conscious of when you're working with inequalities. The process will be, once you've solved for y, you're going to graph them just like you would graph it like a line. Y equals something, basically. But the graph itself is either going to be a solid line or a dashed line. It will be solid if there's an equal sign in the inequality. So if it's greater than or equal to, or less than or equal to, you will draw the graph of that function as a solid line, just like normal. On the other hand, if there is not equality in your inequality, so it's just less than or greater than, no less than or equal to, no equal to, no equal to. If there's no equal to in your inequality, then when you draw the graph, you need to draw it with a dashed line. After you've done that, you've done most of the work. And your job will be to either shade above the line or below it. If you're looking for, if the inequality was y is greater than or equal to, you're looking for y's that are bigger than this line. And y's are bigger than the line as you go up vertically, you would shade above the line in that case. Conversely, if it says y is less than or equal to or less than, and you're looking for y is less than the line, lower than it, you would shade below. And that's about as hard as it's going to get. Slide looks long and complicated with a bunch of rules, but it's really actually quite straightforward when you do it. We'll do a few examples of that and call it a day. Nothing tricky. Okay, so for, well, let's see, maybe this slide's got a better example. Yeah, we'll do theirs. Okay, so here's their example. Graph 12 minus 4y is greater than x. Okay, that's just a mess. So what's the first step, guys? You need to get y by itself, right? Y is greater than, y is less than, or something like that. So let's look at this example. 12 minus 4y is greater than x. So start unwrapping that thing and telling me how to get y by itself. I know it's the same thing I've asked you like 8 times today, but same skill. Probably what? Subtract 12 over, right? Got nothing to do with it. Negative 4y is greater than x minus 12 then, right? Okay. Now, how you get rid of this negative 4? It's attached to the y because it's multiplied, right? So you're going to undo that with dividing. So you divide both sides by negative 4, but a better way, more mature way, in fact, you might as well just start learning right now, is when you divide by a number, you're multiplying by a fraction. So divided by 3 is the same thing as 1 times 1/3. Divided by 7 is the same thing as times 1/7. So what I want you guys to do is I want you to, instead of saying divide by negative 4, let's just say times negative 1/4, the reciprocal of it. Remember that term, reciprocal? Now I just messed up. Did anybody catch it? What did I just divide by? A negative, right? What did I just harp on about? If you divide or multiply by a negative, you have to do what's your inequality. Got to flip it. So shouldn't have written greater than. I should have written less than right there. Be careful about that. All your answers are going to be backwards if you forget that little thing. If you happen to multiply or divide by a negative, that's a problem. So I'm dividing by negative 4, which is the same thing as times negative 4. On both sides, this was just x minus 12, and we've kind of solved for y. It's still a gross mess. I say we go one step further and distribute this in. Negative a fourth times x is negative a fourth times x. Negative a fourth times negative 12 would be positive. What's a 1/4 times 12? What's a fourth of 12? Yeah, so that's better. I like that because that's in kind of slope-intercept thing, right? Very easy to graph. So by hand, I know this thing has a y-intercept of 3. So 1, 2, 3. It's going to kind of cross here, kind of. The slope is negative a fourth, right? So going down goes down 1 every time you go over 4. 1, 2, 3, 4. So right here, something like that. And I'm going to connect them with a line. Now, according to the rules, should this one be a solid line or a dashed line? What do you guys think? Dash. Why? Because it's not equal, right? Equal means when you draw a line with an equation y equals, you're drawing it filled in, right? Because it actually does equal those points. It doesn't actually equal this, it gets close to it. So in this case, you're going to draw a little dash line, just like you said, because it's not equal to, it's just less than. Cool. The only other thing to do is shade. And the question is, should you shade above or below? Do you guys know, looking at the equations? Above? Got to vote for above? 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 You said below. Anybody say above? Why below? It's below. I'm looking for y's that are less than this line, right? This dash thing represents the line, correct? If y's are less than it, well, just if you're on this line, where's y less than it? Y gets bigger up here, right? No, I don't want y's to be more than this line. I want y's to be less than this line. So that tells me to just shade that whole region in, and there's your answer. Okay, your answer will always be some shaded region like that with a dashed line or something, and it's not going to get any worse than that. Let's try this one. Example number 5. Graph this thing. What do they do? Well, what would be the first step here to get y by itself? You'd subtract 9, right? We're going to get some ugly fractions out, so I might as well just do it. So you'd subtract 9 on this example. Now you'd have 3y is less than or equal to 8x minus 9. Without even going forward, are you going to eventually draw a dashed line or a solid line, guys? Solid line, very good. All right. So now I got 3y is less than or equal to 8x minus 9. Our job now is to divide by 3, but what did I just say that's the same thing as? Times what? 1/3. Yeah, that's good to know. So we're going to multiply both sides by 1/3. You could just put it all over 3, but that's a little weird looking. And it's not really set to go. Let's go ahead and distribute the 1/3 in. Now 1/3 times 8 isn't pretty. It's 8/3. But 1/3 of 9 is pretty. That's just 3. So here's my thing that's kind of in slope-intercept formish. I can draw a graph now based on this. Y-intercept's -3. 1, 2, 3. Going to cross down here. Slope is 8/3, so I should go up 8 every time I go over 3. So if I went over 3, I should go up 8. 1, 2, 3, 4, 5, 6, 7, 8. So right there-ish. And like you guys said, it is going to be a solid line, so it should look like this. Cool. Am I freaking you out? Get it? Boring? Too easy? What? Just right. Avery.
I understand it.
Okay, cool. Just checking on you guys. So less than or equal to, where are you going to shade? Above or below? Below, yep, again. So this entire region in here with the boundary included, that solid line is going to be your solution for that right there. All right. I think I've said enough. Would you agree? So you have your linear equations to do and linear inequalities. That will be homework 1.5. Not due till Thursday, but your first priority, of course, is to finish up 1.4 over sketching curves if you have not done that yet. You got a good 15, 20 minutes. You can be productive on something. Thanks a lot, guys.